Greetings and welcome to episode 57 of the Sustaining the Herd podcast, brought to you by Agri-Services and Engineering of Raymond, Nebraska. I'm your host, Andrew Wadle, and joined in the studio with my co-host, Brock Vitek.
Hey there, Andrew.
Hey, Brock. And we're also joined in the studio with our very special guest today, Jenny Pronto of BioProcess Analytics.
Hi, Andrew. Hi, Brock.
Thanks for joining us, Jenny, and we'll give you a chance to introduce yourself and in detail and tell us more about what you and Bioprocess Analytics does. And so we'd like to welcome back our returning guests and listeners. We really appreciate you joining us again for another episode. We always appreciate the feedback that we get, and we appreciate your interest. And we like to think that people are gaining value of what they learn here. You know, everything within the realm of sustainability as it relates primarily to animal ag. And so for our new listeners, just a little bit more about sustaining the herd. What does sustainability mean? Well, what it means to Agri-Services and Engineering is really three things. It means a lot more than that. But the first would be protecting the air and the water. Is how does animal ag coexist with society and keeping the air clean that we breathe and the water that we drink. That's kind of more of a traditional view of sustainability. The second part of sustainability is resource efficiency, doing more with less. If we can get a greater number of units of output for fewer units of input, that is more sustainable, using our resources wisely. And then the last part is often the part of sustainability that's forgotten about. It's kind of the softer side of things, and that is the people and strong businesses. We have to have strong businesses and operating in agriculture in order for that our farmers and ranchers and agribusiness people just to continue to do what they do best, and that is feed and clothe and provide energy for the world. We're going to talk more about providing energy here in a bit, and I think that's a great way to segue to Jenny Pronto to tell us a little bit more about what she does at BioProcess Analytics. And Jenny, I'm going to give you the standard disclaimer that I give all guests that I know, and that is know for a long time, and that is if in your introduction you sandbag it a bit, I will fill in the blanks. And so you really need to give us the business and tell us about you and what you do at Bioprocess Analytics. So again, Jenny, welcome and take it away.
All right, perfect. Thank you, Andrew, for the segue there. And I'll give you a little bit of my background and then hop into the more exciting part of what our company does. So I've had the pleasure, the honor, I guess I will say, of having almost 20 years of my career in the biogas industry. I started in anaerobic digestion, farm-based anaerobic digestion, and have continued to poke along at all parts of the process throughout my career, and I'm still in it today and care deeply about seeing this industry succeed and advance and mature in really responsible ways. So I started off my career in digester process performance, having a really awesome exposure on farm for a good 10 years. I was out there every day with farmers, learning what worked, what didn't work, optimizing systems and learning what really works in terms of an operational farm, putting one of these systems on site. And little did I know how valuable that was going to be for later in my career when I started working as a project manager for what segued the industry from CHP to RNG. And it was clear from the beginning that it was super valuable, the lessons I learned being on farm that much and being able to apply those to new RNG and digester systems for dairy and swine across the U.S. I've worked a lot in greenhouse gas quantification. We did some of the early work on emissions reductions for dairy farms and also digesters. And that also has segued into now working with environmental attributes, LCFS and RINs credits, and also more recently the voluntary credit market. So continue on trying to put valuation on these and trying to come up with a value on reducing these emissions across the agriculture spectrum. So I think that's enough of me. I'd like to jump into bioprocess and tell you a little bit of what we can do. Andrew, you want to add anything?
Well, yes. So what I will say, Jenny, is, and to our listeners, is when you dig into the literature and you start looking at um, digester performance and digester benchmarking, this is the source. Jenny is the source. Jenny's name is on most everything that has come out of the Northeast, dating back the past 10 plus years. She was involved in all of this digester testing that went on. Primarily was in New York State, but it really set the stage for everything that's being done in this area. So again, you've really done quite a service to the industry.
Thank you, Andrew. Thanks. So yeah, bioprocess analytics. We've started this company about a year ago. We did some previous work a good 5 to 10 years ago, and we're kind of restarting it with a full push because after being in development, I see that after all that time has passed, this is still a huge need that the industry has, and a coworker of mine and myself are restarting this analytical services company to really fill in a gap that we see in the industry. There's been a big push of development for RNG systems and agricultural digester systems without a lot of focus on taking care of the actual process that's the heart of this, of a biogas plant. So tracking metrics and testing, routine and analysis and maintenance is super, super important. And a lot of people are seeing that lacking in the industry. And so what we're doing as a company is attacking that from several angles. We have a standardized on-site lab setup that we're selling, a custom lab setup for more advanced or co-digestion systems that we're selling. In addition to that, we service those labs. If you happen to have a lab and already do your testing, we can help you monitor the data, track the data, interpret the data, most importantly, and tell you as you go along, what does that mean? Is it a sign of an upset imminently happening? Is it, showing that there's opportunity for optimization in the system, additional gas that could be produced, and all of that translates to extra dollars at the end of the day. So that's really the focus for this company and the services and products that we're offering.
That's outstanding, Jenny. We have a lot of listeners. We have listeners from a lot of different diverse backgrounds here on Sustaining the Herd. Everyone from farmers to biogas project developers to attorneys, bankers, engineers, everyone under the sun. Mm-hmm. And I say all of that because I'd like to ask if you could, in your own words, describe the anaerobic digestion process. Our listeners have heard Andrew and I do this, but you're an expert among experts. I've quickly gathered that. So keeping in mind that diverse audience that could be listening today, how would you describe the AD process?
Yeah, and you're lucky you got me to answer this and not the lab manager on our team, because he gets real in the weeds. So I'm good at, a little bit more layman's approach here.
Perfect.
Yeah, so for the folks that aren't in the industry or maybe not as deep in the technical aspects of the industry, anaerobic digestion is a biological process where microorganisms simply break down organic matter. Any organic matter, food scraps, animal manure, even sewage sludge, and all in the absence of oxygen. So there's other biological processes like compost that have oxygen present, and those are totally different biological systems. So we're talking here about absolute lack of oxygen. That's why the anaerobic digester vessel, many times you see with a big flexible cover on it, that's to keep the process separate from an ambient environment with oxygen. The byproducts of this process are biogas, which is mainly methane and carbon dioxide, as well as a digestate product, which is a nutrient-rich fertilizer, if you would like to call it that. If we get a little bit deeper into actual biochemical processes, there's 4 main steps, and I'm not going to go deeper than this, so don't worry.
Thank you. That's good. You're on a roll. Keep going.
I've memorized the biochemical things, and I don't go more than that. Hydrolysis, acidogenesis, acetogenesis, and methanogenesis. And the reason that I want to point those out is because this is a sequential process, okay? In each of those steps of that sequential process, there's even more sub-processes that are happening in parallel. And so the reason that I point this out is to show how delicate this process is and how much each step depends on the products of the previous step. So each step produces microorganisms that are totally different and then live and feed on different products. So as you go through this sequence of processes, when something upsets at each of those stages, it affects all the rest of that stage. And what you see at the end is a symptom such as decreased biogas production or decreased methane content. And so it really matters, these sequential process of biochemical reactions and what happens and what needs to be tended to at each of those stages. And that's basically getting back to what testing and analysis on a routine basis will do. You can't wait until you see that symptom and then say, shoot, what do we do now? That's a little tougher approach. Yeah,
absolutely. And, you know, this reminds me of a quote from a client I'll never forget, and you might get a chuckle out of this, I imagine. He cracked me up one time when he said, yeah, I think those bugs can get a bellyache. You know, I think in very simple layman's terms, that's what can happen, right? The bugs,
Absolutely.
The microbes can get a bellyache when things go wrong.
And what happens when you have a bellyache? You don't perform your best, right? You could have an important meeting, be on an important podcast, and have a bellyache, and you're not going to perform your best. So, and that brings another good point that I do want to point out, is that it's not an all or nothing, right? So you could think that your system, I've heard many times people say, well, it's working fine. It's okay. Well, yeah, I mean, even our digestion system is okay. Maybe you have a lot of sugar or you have something that upsets you or some spicy food. You're okay. You can function, but you're not at your best. You're not at your peak. And that really, in my opinion, as an industry, is where we want to push ourselves forward to be at that peak performance and maximize our capacity.
Well, and especially considering the fact that things are kind of lean right now, right, in terms of prices. And so, you know, it's back to that doing more with less. We need to be getting the absolute maximum amount out of these plants in order to really pay the bills, so to speak. So if you look at those four distinct processes and how they all have to be sequential and the one literally feeds off of the other, you know, where is this process most susceptible to upset?
Where is it most susceptible to upset? Well, I mean, I kind of want to approach this in reverse, because the answer to your question, if we look at it in a real life scenario with a real plant operator, it doesn't happen that way. They don't have that information up front. So I kind of want to tackle this in reverse.
Okay.
And what an operator would see first is the symptom, right? They would see before they ever, if they're not doing a routine diagnostic and testing plan, if they don't have a lab on site, what they're going to see is a symptom. They're not going to ever see the lead up to that system, that failure, I'm sorry. So what they would see is the symptom, and that could be decreased methane production or decreased methane content. So either the quantity or the quality of the byproduct is going to change. Even the solid digestate produced, you're going to see physical changes. It's not going to be as liquid. It's going to have some more solids in it because it's not breaking down the way that it should. So all those symptoms are really the first indication that you have an upset problem. And an operator, probably rightfully so, is first going to discard, is there a valve or a piping problem? Is there something physical in the infrastructure that's wrong? And once that's discarded, really the only thing left is the actual process and the biochemical functioning of the digester. And that's most likely where the problem is. So the upset that can happen, and this is all black box if you don't have testing, but if you have testing, what you would see in your data and the results of those analyses is higher VFAs, and VFA is a volatile fatty acid. You would see the concentration of that increase. You would see a pH decrease, and many operators would call it, I have a sour digester, my digester's sour. The pH is decreased. Obviously, like I said, biogas production and concentration of methane decreases, and the volatile solids, like I said, the physical presence of solids in the digestate changes. You're not going to see any of those changes if you don't have analysis that gives you the data to know what is happening there. If you do have that data, you can go all the way back to the beginning, and the answer to your question, Andrew, is the reason for that upset is going to be either an operational parameter or a feedstock change. So the operational parameters that would cause an upset like that would be a change in the loading rate or the loading frequency. Are you putting more material into the digester, or are you putting it more frequently? Because if you're putting more concentration of material in there or more frequently, the flow of those sequential 4 steps that I described before is going to be upset. You're putting raw material in when it's more at the end of the process and in different concentrations than it's used to. Temperature is a huge one. If something has failed equipment-wise and the temperature regime has changed, that's a huge indicator that you're going to have changes in those biological processes, and the microorganisms are not going to work the way they should. Agitation and mixing is the other one. If there's a change in frequency or speed, I've seen somebody didn't even know a mixer was broken. A blade had broken off inside, and there was actually not the agitation they thought was happening. The communities of microorganisms don't mix the way that they should. So there can be physical operational parameters that change that can affect the biochemical processes, or the concentration, the characteristics of the feedstock can change. Is the solids different? Did you have a huge rain event? When you have more liquid material going in there than you normally do. Did you add new substrates? Did you add high strength food waste? And the bugs are like, wow, what is this stuff? It's just like if you eat a chocolate cake. Your stomach, it's a huge load of sugar. Your digestion's not used to that. So those are all the way back from the end symptoms that can be seen all the way back to the beginning, to answer your question, Andrew, of what would actually cause an upset.
Yeah. So Jenny, you mentioned adding new substrates like high strength food waste, and that makes me think about co-digestion, which seems to be becoming increasingly popular. As Andrew mentioned, things are a bit lean now, markets are a bit tough. So folks are looking at more and different feedstocks to produce gas and ultimately generate revenue. However, you mentioned maybe there was a change in operational conditions or something happened that causes an upset. Well, from my perspective, if you're in the business of co-digestion, that means you're in the business of dealing with operational changes potentially daily, if not several times a day, depending on what feedstocks you're all receiving. So could you just help our listeners understand what is co-digestion and how does it affect the operation of a digester?
Yeah, definitely, Brock. So co-digestion is basically co-digesting multiple substrates. So a typical anaerobic digester, I would say, from the agricultural perspective, would be an animal manure only. And animal manure is a great material and a great candidate substrate for anaerobic digestion. It's got buffering capacity. It's pretty consistent in nature. It doesn't change the quality that much, and it's pretty consistent in terms of the quantity. So we have a consistent characterization, a consistent quantity, and a great buffering capacity. That's going to do well for us in an anaerobic digestion sense. Not to say we still don't need to have some routine maintenance on those systems, but when you throw a co-substrate in there, and it can be 1 to 20 to more, you need to have better eyes on what's happening with that process, because those additional substrates can vary, and they can vary pretty widely, right? They can be high strength. You can have a fog material, fat oil or grease. You can have a product that's more acidic. When we're looking at food waste across the consumption spectrum, it can be anything. I've seen beer, toothpaste, dyes, coffee, anything, really anything. And it's not to say that they're not good candidates. They need to be managed well. The other issue that you confront with that is that they're varying quantities. So you might get a slug. I saw a picture the other day of a person had a truckload of tomatoes. The bugs in that digester have potentially never seen a tomato before in their life, and now they've got 5 tons of tomatoes to deal with. That poses some challenges to the system. Again, not to say it's not possible, but it needs to be done responsibly and well to not overwhelm those biological processes we talked about. The other challenge is the varying quality. If we have something like source separated organics from a grocery store or from a food waste collection system in a city, the quality of that is going to change. There's plastic, there's vegetables, there's meat, there's, rotten things. There's a whole scheme of compositions that those bugs have never seen and need to learn how to deal with, and that could potentially pose some challenges. So a co-digestion system can pose great benefits for us. It's going to have a great amount of gas, potentially, depending on what those substrates are and how much we add. But we definitely have to be responsible about incorporating them in a way that is not going to crash our system, basically.
Sure. Sounds like
Yes.
the black box approach doesn't cut it there. You need to monitor closely.
Yeah,
Yes.
it would be good. Yes.
And I'll also mention in an unrelated subject, and because I'm sure there's digester owners, operators out there that are getting really excited about hearing this. Everything is true what Jenny's saying as far as making more biogas, but don't forget that what comes in goes out, and so we have to remember that we do have increased nutrient loading. That has been a subject in past podcasts, and will surely be on another. But I just wanted to mention that to all of our guests. That
100%.
Might
super way
add
to
to
make
that.
more. Super way to make more gas, but you also get more other stuff as well. So from everything that I hear you say as it relates to the process, there's a number of different places in a system, and we always talk about the system. There's a number of places in the system that I can think of that you could and would want to be testing. Tell us what you would see as being the ideal consortium of tests to get the right results to be able to make meaningful management decisions.
Yeah, definitely. So there's two answers to that, and I would say that one would be upfront prior to the development of a project, so that you know the characterization of the waste you're looking to put into a system. Even when it's manure only, it is a smart idea to take a look at what is composed of that manure. Is there sulfur in the groundwater? Is there a higher solids concentration because of some specific management technique that they use? Even if it seems subtle, it can be magnified later on in the system. So even up front, it's really important, and especially with a co-digestion system, it's important to look at characterizing your waste before you design the system. It's just a responsible way to do it.
I'm just going to stop you for a second. Can you tell us, characterize the waste? What specifically does that mean?
So a lot of people have heard of biochemical methane potential tests, so BMP test. That is a more economic, upfront way to take a snapshot look at the value of the biogas potential in a waste. It's not the only way, and it is definitely not a direct comparison to design a system to that capacity. There's batch tests that are over time that look at the value of the biogas that can be produced. It's a balance of how much you're going to spend on doing those tests and seeing the value of the biogas that is contained in a substrate up front. But those are, you probably have heard of a BMP, and that is probably in the industry what the most typical approach is to measure those up front. Again, not a direct comparison that you can say it produces this and so we'll design for this. That's not how it works, but it gives you a good idea of the value of biogas potential in a substrate. The other place, and really where we focus our efforts in terms of testing and analysis, is after a plant has been built. You hand it off from development to operations, they're ready to run. They don't know how to take care of the actual biochemical process of the system. They need to have an on-site lab, which we can deliver, that will provide weekly maintenance and routine diagnostic testing. And I'll give a list of those few parameters in a minute. Train the staff on how to do that the right way, because any data that's not collected in the right way is, at the end of the day, not helpful to us. To collect that data and to manage the data. So I've seen a lot of times that a plant is doing a great job testing, analyzing, and they just put everything in a folder. And a year later, they're like, well, we've got all the data, but nobody ever looked at it. Nobody ever interpreted it. It is important as you go along and collect those, the values for those parameters, to watch what's happening. And for your operators to know their system well. What is happening, what works well, what is normal. Because maybe something at one site is a lower pH, and that's totally normal for your site. might be at the lower end of normal or the range of normal or higher, but knowing your site and what is normal in your site, because that's going to allow you to see anomalies that are happening, and that's when you know that something could go wrong, and it's important to track that. So some parameters that are pretty typical to follow in terms of I'm going to use a manure-only system here, because if we have substrates, there could be specific other parameters that depend on what that substrate is that we would want to track. The volatile fatty acids are a great indicator that if you see the concentration of VFAs, I'm going to call them from this point, if you see the concentration of those increase, you know that something is happening. It indicates to us when we see that methanogenesis is not happening. So if that's not happening, we're not going to get methane production. So that's a great standout indicator to us that something is happening, and we need to go back and see what, and kind of backtrack the analyses. So other things, temperature, like I mentioned, it's pretty easy. I think every system, now that would be built now would track temperature. It's really important to keep an eye on that and make sure it's within the range of normal. Solids, very simply volatile solids and COD, which is chemical oxygen demand. All of those are under the panel of solids testing that we would do. And the tracking the solids indicates the performance of the digester, basically. So it's based on the level of the destruction of the solids, how well that digester is performing. Other things, we would call them confirmatory parameters, for example, pH. If the pH, for example, the pH will go down when the VFAs go up. So if we see that happening, which is a little bit more sensitive of an indicator, again, we can know that something, we get kind of a tip off that something is about to happen. And at that point, seeing that pattern, we can do something about it before it becomes a problem. Alkalinity, the buffering capacity of a digester is important because that helps to maintain the pH within the appropriate range. pH is more sensitive. If the alkalinity becomes out of range, again, it's easier for the pH to change, and that'll have immediate consequences. So we want to keep track of those more broad parameters to make sure that the sensitive ones don't go out of whack too quickly. Methane content is another one. Either, I think I mentioned before, either the quality or the quantity can change in that end product. So the biogas production quantity or the quality can change. And if we see the methane content decrease, that indicates an issue, again, with that step that's called methanogenesis. Increasing the CO2 concentration and decreasing the methane shows that there's something out of balance with that step in the process.
So of all these tests, which ones can you actually perform on your own in your own AD lab?
All of those
all of those, they could all be done, with someone, not somebody with you don't have to have a PhD in chemistry to run these
Andrew,
tests.
even I can do it.
Wow, there's hope even for engineers, huh?
Yep. So all of those would be contained in our standard on-site lab package for a manure-only system, and they're important to do, like I said, routinely, ongoing, in a consistent schedule, and to manage that data and watch it as it's collected.
Okay, and then just a word about BMPs, because I think there's actually a lot of labs been made doggone rich BMPs because people love BMP testing but really at the end of the day, do you have any rules of thumb that from BMP to actual performance, how much would you reduce a BMP? How much would you advise a client to reduce a BMP to get to actual production? Any rules of thumb? Any idea there?
No, I mean there's definitely not a hard and fast rule at all, and I would say that the BMP is one step. If you're looking at a system and characterizing the waste going in and trying to come up with an actual quantity to design for, you need to look at things that are going to inhibit that process. Different mixes of substrates that are going to be antagonistic or synergistic and create even more. So it's not a 1 + 1 = 2 kind of scenario. It gives us, like I said, a snapshot to have a good idea, but there's not a hard and fast rule to say, if I got 10, I can scale up or scale down a certain amount. That it doesn't exist yet. it's just an indication of the direction we can take. And then there's definitely other parameters that we need to take into account to come up with an actual design capacity.
Yeah. Okay. We also tend to remind clients and folks that the BMP, if it's what I would consider standard BMP, it's a gram. It's a gram of material or thereabouts. And so you're looking to make a pretty big prediction based on a gram of material.
And I'll go back to the sampling. For me, I'm a stickler, and I've come up with SOPs for sampling, and I know there's some great ones that exist in the industry with other agricultural institutions. The number that you get is only as good as the procedure that you follow to get there. You need to get a good sample, which is not easy with the systems we're talking about and the quantity of manure we're talking about.
Sure. Right. So, building off of all that, Jenny, are there any big misconceptions about the anaerobic digestion process that you come across in your day-to-day? If there's just maybe one or two bigger ones and that you would like to, dispel those myths, those misconceptions.
Yeah, it's like bioprocess analytics mythbusters here.
Mythbusters.
Exactly.
Oh boy. I guess I'll kind of take this one from the perspective for the folks that are not really inherently connected to the farming or agricultural perspective, because I've seen a lot of times engineers and people from other industries, oil and gas or solar, that jump in and hop over to the biogas space. And I don't think they realize what a delicate process the actual biochemical portion of the anaerobic digestion process is. It's not a set it and forget it thing. It's not I'll design this tiny vessel on my P&ID and say that it's in between this and this. It's not how it works. It's more than top of the line infrastructure, the best of the best equipment, and really none of that's going to matter if the actual process becomes upset because the biological portion is not tended to, and it cannot follow that sequential flow of those four main steps that I mentioned before. The balance and the inner workings inside the actual vessel is literally what we physically cannot see, and that is all of what we are focused on at BioProcess Analytics, is giving you an insight into that vessel that's physically closed, that sometimes has a tiny window with a little windshield wiper, that you can see.
Little windshield wiper that never works.
That never works.
It's like, what do you see? Well, it looks like manure.
Yeah, everywhere. So, I mean, that part is the heart of the plant, and I would venture to say that it's the least tended to, and that's really why we care so much about giving operators and developers a window in to see what's happening inside that black box. I think that's kind of a misconception that it's just a box on the BNID.
Yeah. Well, that's great. The bioprocess analytics it's the window into the black box. This is
There you go.
Brock and I don't normally give marketing advice, but there you go.
I see where you're going.
There you go. All right. Well, final question I have, but before we get this start to wrap up here. Just a fun question I'm curious about, Jenny. Is there anything that's not substrate or feedstock related that can economically be added or to a digester to increase gas production, whether it's some type of additive, or maybe it's like pre-treatment equipment or anything equipment related, you name it. Is there one or two things that would fit that bill?
It's a really interesting question, and the answer is there's several answers to cool things and innovative approaches that are being tested right now. Everything from additives, like you mentioned, enzymes, which would increase the digestibility of a substrate, therefore translate to higher gas production, electric impulses. There's so many different innovative approaches that are being piloted right now and really across the world. But I don't know if I'm going to disappoint you with my response here, but our take and really our niche is to go back to the point that we made at the beginning. Right now, and what bioprocess analytics needs to focus on, and I feel like the industry needs, before we jump to the point that you're trying to get at, is to max out the capacity of each and every one of these plants, because it's not maxed out. You need to make the best use of the process that you've already paid for, millions of dollars that you've paid for, and is potentially operating below capacity. We need to make sure that that works properly first before you ever consider putting additional capital towards one of those innovative approaches or an enzyme or an additive. We work with those companies. We love to have, partners that have those innovative solutions. We test them sometimes. We're happy to, be involved in that. But I'm a strong advocate for, before you do that, you need to max out the capacity of the system in and of itself, by itself, for several reasons. Number one, because it's just the logical approach. And number two, because if you don't, there could be something happening in that process that's going to prevent you from taking full advantage of one of those products that you're going to be paying for. Maybe your pH is off, and it's something as simple as that. Maybe your alkalinity is up. And if you don't know that, and you go ahead and put more capital towards one of these products, potentially you're not going to see the full benefit of it. So it's really important to know your system, to test your system, max out that capacity, get the maximum biogas, and then say, you know what, we're ready to move on to the next level and advance our kind of optimize our system.
I think that's huge advice. Yeah, I always, we always relate things in business back to sports, and it's like, do the basics really, really well. The people who do the basics really well, whether it's milking cows or feeding cattle or running digesters, do the basics better than anybody else, and you're going to get the results better than anybody else.
That's a strong foundation upon which you can look at some other things later on.
Absolutely. Yep. And it's really, talking about cost and inputs, you already have paid for this. You just need to make sure that you're tending to it well, taking care of it, and please leave the line item in the operational budget for analysis and routine testing. Please don't take that out.
Yeah,
I've seen it happen.
For sure.
Duly noted.
Well, Jenny, this has really been an enjoyable conversation. I know Andrew and I have had a great time, and I'm confident that our listeners have all found something of value here. So thanks again for your time and expertise with us today.
So Jenny, if folks would want to contact you to talk about what bioprocess analytics can do for them in terms of really maximizing their investment, how can they get a hold of you?
Yeah, sure. So bioprocess analytics is, we're on LinkedIn, and we've got a list of services. We've got some sort of marketing material that you can take a look at, our list of services and such, or shoot me an email, jenny.pronto@bioprocessllc.com.
Perfect.
Very good. Thank you, Jenny.
Yes, thanks again, Jenny. And I would like to say thank you to all of our listeners, both new and returning, who have chosen to spend some time with Andrew, Jenny, and I here today on this episode. We really appreciate all of you tuning in, and we look forward to being back with you again in a couple of weeks. As always, until next time, thanks for joining the herd today.